Hi everyone, welcome back. Today we're doing keyboard row in Java. We're given an array of strings words and we have to return the words that can be typed using letters of alphabets only on one row of the American keyboard in the image below. So the first row contains these characters Q, W, E, R, T, Y, U, I, O, P. And similarly for the second row, if you put in all the characters in the second row, you get this. And finally, third row consists of this. So if we are given four words, hello, Alaska, dad, and peace, in this case, Alaska would take up only letters on the second row, and dad in this case would also take up all letters in the second row as well. So we return both of them. For the second example, in this case, OMK, O, M, and K, all three characters appear on three separate keyboard rows, so that is not in the answer. And finally, for these words, in this case, AS, AD, SDF, in this case, this uses only the characters in the second row, and SFD, in this case, only uses characters in the second row. So let's talk about the constraints. Like, all the words given to us would range from 1 word to 20 words, and for every single word, there's up to 1 to 100 characters. And words consist of English letters, both lowercase and uppercase. This is an important detail which we'll talk about in a bit. So let's talk about how we would do this. One approach we can do is to iterate through every single word inside this words over here. And for each of these words, we take the first character and identify which row, whether if it belongs to the first row, the second row, or the third row. And once that is the case, we would use that row for the subsequent checking of characters. If subsequent characters do not appear in that row, then we would set that word as an invalid word. If the word is still valid after this check, then we will add it to a final string array and we will give it back as the answer. But of course, that's the high level logic. There's a couple of details that we have to think about too, which is how do we optimize for searching whether if a character belongs to a keyboard row or not. So one way we can do that is by using a hash set. A hash set allows you to search for an item in that data structure in O1 time as an average time complexity. So if that's the case, what we can do is we can pre-populate every single character on every keyboard row inside their hash sets, and we will identify which hash set to use for each of these words. That was quite a bit of words, but so let's quickly go into the logic. So the first step would be, the pseudocode would be to populator. Oh, of course, I'm using Python's way of commenting, that's why. So the first step is to set up 3 hash sets, each hash set representing the characters in each row. The next step would be to iterate through every single word, and for each word, get the first character and identify which row the character belongs to. And once that is done, use that same row to check if subsequent characters belong to that row. If not, mark it as invalid. If word is still valid, after checking every word, append that, add that to an array list, and convert it to a string array at the end. So that's pretty much the idea. So let's get started on the first step, setting up the hash sets. So in Java, in this case, we can use the hash set data structure. So let's define the first row. Let's define the hash set. And hash set in this case would contain characters. This is a box type because unfortunately all these hash set objects over here takes in only box types. So this will be our first row, and to get it, we will just do arrays.aslist, and we will pass in all the characters that belongs to the first row. So notice that in this case, we are using only lowercase characters on purpose. And what this means is when we check whether if a character exists in this row, we'll be lowercasing it first before we use it. We also do the same for the second row. Okay, so in this case, A, S, E, F, G, H, J, K, L. And finally, this is the final row, the third row. We're using arrays as list to take in a sequence of characters, and each of these characters would exist inside this hash set. So I think I made a mistake. This returns back an array of characters. We would still have to convert this into a hash set. So let me wrap this into a hash set like this. So we are passing this array of characters into the constructor of the hash set to create a hash set. So that's about it. But to make it more readable for our viewers, perhaps I should have abstracted this. So let's do list of characters equals to first row list equals to this, and we will pass in this first row list instead, just so that it's clearer to our viewers that we are initializing this list of characters first. Okay, so let's copy this and paste it here. Of course, don't forget the semicolons, and pass this second row list into the constructor. And also, let's define this third row list, and let's start to populate this. Okay, first character is Z, S, X, C, V, B, N, M. Okay, and now we can define the hash set. Okay, and we are done with the first step, which is to initialize the hash sets for quickly checking if a character exists in any row. Now the next step will be to iterate through every single word. So for string word in words, now we have this. Let's initialize the word row. So this represents the hash set that we should be using for this row. So let's call this current row. Notice that we haven't initialized it yet. We'll be initializing that in a bit. So the first step to do that is to get the first character. So character char first char equals to word dot char at 0. And this character over here can be a lowercase or an uppercase character. So to do that, we'll be using the static method under the character class, and we will be doing to lowercase, and we will pass in this primitive character to lowercase it. Now that we have this first character, we can proceed to check if it exists in the first, second, or third row. So if first row contains first char, then what this means is we'll be using the first row as the current row. Else, if the second row contains the first character, then we'll be using the current row as the second row. Else, the current row will take on the third row. And that's about it. So this current row will be used to check if subsequent characters exist in this row. And if that's not the case, the word is not valid. So let's define a boolean, and this will be is valid, and this will be set to true. We will consider a word as valid until proven otherwise. The next step will be to start iterating all characters from the second position, index 1, onwards to the end. So index I equals to 0, I less than word.length, I plus plus. And using this I, we'll be getting the corresponding character. So char current char equals to character dot lowercase. Similarly, we will lowercase every character that we see, and char at I. And if this current character doesn't belong to the current row. Then what this means is this word is not valid, so we set this to false and we can break this search. Once we notice that one character does not belong to the current row, we can terminate the search because we know that it's invalid. So if this word is still valid afterwards, then what this means is this is part of our answer. So there's one step which I forgot to initialize, which was to create an array list, a variable list that changes in size, as the answer. So let's define this array list, and this array list will contain all the words that are part of the answer. So answer equals to new array list like this. So once we're done, we will add this word into this array list if it is valid. And at this point, once we're done, notice that at the top of the solution function signature, we need to return a string array. So we can take advantage of an array list method called toArray. So toArray. In this case, this array over here, this method toArray will return an array of objects, which is not what we want. We want an array of strings. So to convert this to an array of strings instead, we will pass in the type of a string array, and we'll pass in the constructor new to ask this toArray method to convert this array list of strings to a string array instead. So now let's quickly look through everything and try tracing this out with a few test cases. So let's try out with this test case. Words equals to hello, Alaska, dad, and peace. So now currently our array list is empty, so answer equals to empty array like this. Now let's set word to be equals to hello and let's get started. Now current row is set to nothing, so we'll set this to nothing for now. And the first character in this case is the first character in word, so this is H after we lowercase it. So in this case, does the first row contain H? In this case, no. Does the second row contain H? In this case, yes. So current row will be set to the second row. So I will just set it as this, but in summary, you're really just referring to, we'll be setting this to an array like this. So it should be like this, where current row is a copy of the second row list, but it's okay. I'll just set it as a second row for now. So now is valid is true, and currently I is equals to 0. Thinking about it, I think I made a mistake here. We can just check from the second character because we have already used the first character to get the row. So we can save one computation by using I equals to 1 here. So I equals to 1. Current character will be at the second character. So in this case, current character will be equals to E. And in this case, we check whether if E exists inside the second row. And in this case, we can see that E doesn't exist in the second row, so hello is not valid. So we will not be adding hello, we will break it and we'll carry on with the next word, Alaska. And let's carry on with this. So current row is now set to an empty row. We will remove all the previous computations here. And we will continue tracing on line 29. So the first character in Alaska is A. And in this case, we will check if A exists in the first row. It doesn't. But A exists in the second row, so we will set the current row to the second row list. Sorry, second row. Just the hash set second row. And now, is valid will be set to true. And now we'll be checking from the second character, L, in this case. And L in this case exists in the second row, so this is L. Sorry, I equals to 1 and current char equals to L. So this is fine. We'll continue. Now we're looking at the third character or index 2. Now this is A. A exists in the second row, so we continue. 3. Now we have S. S exists. 4. K exists. 5. A exists. So in this case, all characters in Alaska belongs to the second row, so we would have is valid equals to true. And since this is valid, we will add Alaska into this array list. At this point, you can see where this goes, but this is pretty much how it works. Now that we have done a sanity check, let's run this code against some test cases and let's see if this passes the test case. This works. Let's submit this. And there we go. So now we can go through the time and the space complexity. And in this case, let's talk about worst case. And in this case, let's go through this. So over here, we have the initialization of the first row, second rows, and third row lists and hash sets. In this case, if we let n to be the number of words and m to be the number of characters, in this case, the initialization will take constant time regardless of n and m. So this would be O1. So this initialization of array list is O1 as well for now. And in this case, on this line, we are going through every single word. So this is going to be ON at this. And now let's take a look at the iteration under this for loop over here. So this is going to be O1. This is going to be O1. All of these computations will be O1. This is O1. And we are going through every single character over here. So this is going to be OM. In the worst case, if the word is valid, you're going to go through every single character. So in this case, this is OM. And a small little detail over here, if we are to really talk about the worst case time complexity of checking for a character in a hash set, actually that would arguably be, or it will arguably be the size of this hash set over here. But in this case, the hash set has a constant size irrespective of n and m, so this is going to be O1 regardless, even if we take it as a worst case time complexity. But just so you know, like in the worst case, this can be, if n is the size of the hash set instead, then the contains can be very inefficient. It can be up to ON. But in most cases, like in most real world cases, if there are no collisions happening in your hash set, that should be O1. So anyway, for the sake of simplicity, let's just consider the check for first character in second row to be O1 in this case. So regardless, all of these computations in this nested for loop is going to be O1. So this is also going to be O1 as well. So in this case, the time complexity in summary for this for loop, because this for loop has a for loop nested in it, and this nested for loop is going to take up to OM time, and the outer for loop is already going to take ON time. This is going to be ON time M. So this is pretty much the time complexity. And in this case, we are also going to convert this answer to array. So unfortunately, to convert everything to an array, this is also going to take ON time in this case. So that's pretty much it. So in summary, the time complexity is ON time M plus ON. But if we remove the term of the lower power, it will just be ONM like this. So now let's take a look at the space complexity instead. Okay, so over here we use the amount of memory used for initializing the hash sets is not dependent on n and m, so this is going to be O1. They are just a fixed size, and this is O1 currently. So but this answer would contain as many words as valid words. So in the worst case, if words consist of only valid words, then your array list over here would take up to ON space in this case. These are temporary variables, so they will use constant memory. This will also use constant memory, so that's fine. So in summary, this is going to take up ON space. And if you really consider the output over here as using space, this is also going to take ON as well. So in summary, this is going to take up ON. And if you wish to be very pedantic and keep track of the memory used for every single character too, then this is arguably ONM as well. And same for this. So in summary, the space complexity is ONM as well. But if you want to consider them only with respect to words, then both time and space complexity will be ON. So in summary, that's pretty much it. Yep, that looks fine. So I hope this was useful. If you like it, please give us a like and subscribe, and we will see you in the next video.